So the 17th problem in lead code is the letter combinations of a phone number. So basically, we'll be given a two digits and we'll have to find out a combination. So before actually starting to the problem, if you know this keypads right in the old mobile phones, let's say that if you want to type any message, let's say that if I want to type A and D, right? So what I will have to do is I will have to press 2 here and 3. So as A is mapped to 2, right? ABC is mapped to 2 and DEF is mapped to 3. I will have to press 2 and 3. And similarly, if I want to say B and D, for example, B and D, what I will have to do is I will have to press the button twice. Like I mean, I will have to press twice this button, like I mean 2 and then I will have to press 3. So it will give me the result as B and D. Okay, that's how the keypad works. Okay, so basically, what we'll have to find now is we will be given any two digits or any four digits, like from 0 to 4. Okay, like it can be nothing, or else we will be given four digits. We'll have to find out the combinations out of it. Okay, so let's say that in this example, it is given that two digits is given 1 2 1 3. Okay, so now what we'll have to do is try to find out the combinations, right? I can press 1 1, like let's say that I can press this once and I can press this once. Okay, so what would be the answer? A and D, right? And I can press number 2 as for once and I can press this twice. Correct, in that case what I will get? AE. Similarly, right, we'll have to do all these combinations and print the result. We'll have to return the result. Okay, and now before actually starting to this, right, so basically what is happening here is, let's say that let's assume that this will be usually mapped to the number 2, right? This is mapped to 2, this is mapped to 3, and this is mapped to 4. Correct, so let's say that we will be given 2 3 4 number. So what we'll have to do is basically the combination goes like this, right? AD and then G, and similarly ADH and ADI. Correct, and the next combination would be something like AE. Okay, and again the same thing here, AG and AEH and AEI. Correct, so this is what is happening. So if we just write it in a good way, right, let's say that we are here. Okay, let's say that we are starting from here. What are the combinations I can get? For A, I can get a D, E, and F. Okay, and for a D, how many combinations I can get? I can get G, H, and I. Okay, similarly it will also go to this, right? Three combinations I can get for D. Okay, and for A I can get D, E, F. Correct, so now what do we need to do here, right? We'll have to find the combination basically from the root node, and this is one node, and similarly B will go here and C will go here. Okay, A, B, and this is C. And for again B will be getting three combination, D, E, F, and C is also D, E, F, and internal D will get three more combinations. Let's not try to that. Okay, so now what will happen here is we'll have to try to find the combinations. So combination in the is nothing but a path here. Correct, I can go traverse in this way and ADH, and once I reach the end I will have to go to the different route, right? I will have to go to AD and this path. Okay, and then this path. Correct, so now what are the combinations I got out of A for D, right? ADG, ADG, ADH, ADI. That's what we actually show there. Okay, okay, so basically like looking at this tree approach, right, what we actually tree approach, and also basically we are trying the combination, right? We are trying to find out the combinations here. When it comes to combinations, we usually have to go with the backtracking method. Okay, and also here we could clearly see, right, as we can clearly see that we are traversing by taking a step back, right? So basically what is backtracking? Backtracking is nothing but, let's say that we need to let's say this is a 2D grid. Okay, like we have so many things here. Okay, 2D grid this is, and let's say if I want to reach from this point to this point, what I will do is there can be a number of ways, right? Let's say that if I take this path and there is some blockage here. Okay, I cannot go to further this. So what I will do, I will go to here and then realize that it is the end. Like I mean, I don't have a path, I need to take the step back and I will have to try to the different path, right? I maybe like I mean there we are will be exploring the different paths. When we reach some dead ends, okay, this is a dead end and we cannot reach that path, like maybe we will take a different path, we'll take a step back and go it, right? That's what is similarly happening here. And we will use the same algorithm. I mean, basically we'll use the backtracking algorithm to find the combinations. So whenever we need to find a combination, we'll have to go with the backtracking. And when we say backtracking, it's mostly implemented in a recursion way. Okay, so now whatever the things we discussed here, right, ADG and ADH, and how to implement is the question now. Okay, so now coming back to the code, right? So let's say that we don't know the mapping, right? We'll have to first, when we are typing it by visually we can see it and we will double click it, but we need a mapping. Okay, so we'll prepare a mapping to what is 2, what is 3, what is 4, what is, all those things. And now when we want to backtrack it, actually, let's say that I will start the backtracking from a letter character, from the first digit basically, right? Let's say that this is a 2 3 and I will have to start from 2, right? So what we'll do is we'll say initially, let's come back to this. So let's say that this is where we are going to start. We are taking an index, so we'll have to return as 0. And whatever the result we get, right, we'll say it as a path. Okay, combination we can also call it as a combination, and we can call it as a path. ADG is one path, right? ADH is one path, ADI is one path. Okay, so we can either way, if you are comfortable, we can call it as a combination, or we can just call it as a path, as we discussed just now. Okay, so currently we don't have anything, right? We'll declare that path is empty and we'll be starting from the first digit. Okay, so now here we are here now. So what will happen is, so let's say that we'll enter the loop. Okay, let's ignore this for timing. This is an exit condition for a recursion function. So we will have to read the, let's say that now we have received the 2 3, right? And index is 0 now, so we'll have to get the two, like, I mean, digits of 0 is nothing but the first digit mapping. We'll have to get the first digit mapping, and then we'll iterate through this character A B C. Okay, and we'll get this. Okay, we'll iterate through that character, and the first character is A. Now we will change the backtracking. We'll do the backtracking again, but this time we'll go to the next one. So what is our goal here is, like, looking at here, right? At first we'll be here, right? And then we'll have to go to the next node, correct? So that's what we are trying to do here. So we'll be starting the backtracking, and initially we were in the first one. So our answer was, like, I mean, the initial character whatever we have, right? Whatever the character we are at, it is at A. Okay, and then we'll track the next one now, like we'll backtrack the same thing, like in the next available thing. Okay, DEF, right? So when we increment it, when we increment our index, so basically we are checking the next digit. What is it? It is a 3 now, correct? We are trying to backtrack that. And so when we enter the loop, we will check it here. Okay, like, I mean, are we at, let's say that, what is the exit condition in the tree? We'll need an exit condition, right? What is the exit condition here? When we reach the leaf node, I mean the end, we'll have to stop it there, correct? What is the end here? Length, whatever the length of the characters, right? Let's say that here it is a 3 digits, correct? When the and also we need to make a combinations here of a 3 digits, correct? So how what we are trying to do is, length of path is 3, correct? ADG is also 3. And how much, what is the length of combination we need to build of, that's also 3. Okay, when we reach that condition, we'll stop that combination there, right? ADG is the final one, because that is the, like, I mean, we reach the end here basically. Or the other ways, what we can say is, length is same, ADG is nothing but equal to 3, and whatever the combination that we need to do, right, that is also 3. Both are same, so we will stop the backtracking there. Okay, so we'll come here and we'll draw, so for example, now when we started with the 2 3, right? So we took the character A here. Okay, and we are going to going for the next string here, next button. So it is the 2 here, and we'll be sending out the we'll be incrementing the index here basically. And here, what will happen now, length of the path, still it is nothing but a path was empty here initially, it is A, correct? So now what will happen here is, this is nothing but what we are sending is the path, as we are sending path as A here. Okay, and length of path is 1, length of digits is 2. This is not equal, right? This is not an end till now. So we'll come here again, and this time, as we have incremented the index, we will be iterating through this node now, DEF, correct? So what will happen here? Okay, so we are trying to backtrack that similarly, like we had A initially, like, I mean, this in this path we already have a A. So A plus D, we got a combination called AD. Okay, and then we'll try to increment the node. We'll see like if there is any other buttons that we need to look for or not. Okay, so the now the index has become 3 now, like sorry 2, like 0 1, and now we got the index as 2, and this path as AD. Okay, and when we come back to this backtracking, we'll see the length of the path, right? Length of the path is nothing but whatever the path has become now as AD, correct? A length of AD is nothing but equal to 2, and length of digits is also 2. It means that we have reached the end, correct? Like I mean, whatever the combination that is we needed, right? This is the one. So we'll append it to the result and we'll return back. Okay, so now when we return back, we are still in the D iteration, right? This we are iterating through this DEF. Okay, so next we'll read the E character and we'll do the same. Okay, so we'll do the same. In this time what will happen is, initially the path was A, initially it will become AD and AE, AF. Similarly in this iteration it will try the different combinations, and it will keep on adding this keep on updating the result variable, and at the end we'll be returning the same. So basically to summarize here, right? So whenever we need to approach a problem which wants the combination, which wants to try the combinations, right? Which we want to get a combination of the result. So we'll have to make use of a backtracking method, and one simple way to analyze is just by drawing it as a tree, right? It will be clear for us if the backtracking mechanism works here or not. Okay, and also thirdly, like I mean, when we say it's a backtracking, it's mostly comes with the recursion. It's a recursion, right? Like I mean, we'll have to write a recursion function here, and we'll have to come up with a logic that will break the ending loop. Like it will be different for different condition, right? Here the ending is when we reach the how we are going to determine we are at the end. It is how, like I mean, if we got a combination, right? If the whatever the combination we got, that length and also length of the digit that was given, if it is matching, it means that's the end. So we'll consider that as a result, and we'll be coming back. Let's say that we'll coming back and we'll trying out the different combination. Like initially we went to AD, right? In the first iteration, in the first call, like we'll be iterating through this ABC, and for each ABC we'll be calling this basically, right? Like we'll call once as a D, and we'll say that okay, the ending is reached, and then we'll come back, we'll check for E, check for EF, and we'll make a combinations out of it, like that. Yeah, that's it. Yeah, thank you.